obviously during the webinar, please use the chat facility or put your hand up and certainly put your questions to us. Time may not allow us to answer all questions, but we will endeavour to get a response to you post the webinar. For your information, we're recording the webinar. We will make that available to those who wish, and certainly will send slides to all attendees. We also will hope that you might contribute to a short survey, which we'll also include with a copy of the slides. So moving on to the next slide. Okay, so who is the new Sustainable Building Model Limited? We're a design and build company with a vision of achieving the best environmental performance and affordability outcomes from our buildings for people, communities, and the planet. And our aim is to deliver in use now an eco-efficient framework which allows design and build to happen in a more optimal way. Circular Ecology Limited, our environmental consultancy, who also provide online and bespoke training courses. And as I said, Dr. Craig Jones will be the co-host. In developing the NSBM Eco-efficiency and our tool, we adopted the Richard Buckminster Fuller's approach and thinking. If you never change things by fighting existing reality, you change something by building a new model and try and make the other models obsolete. So that's been our ambition. Underpinning our approach, we've been driven by the principles of eco-efficiency, which, as I'm sure you're all aware, is using fewer resources, creating less waste and pollution. And then in terms of the circular economy, which is clearly important, we want to move away from the traditional linear economy of make, use, and dispose. Clearly, that's not very sustainable, and we aim to try and keep resources in use for as long as possible. And just to be even more ambitious, we want to think about cradle-to-cradle design philosophy, trying to mimic nature's processes, viewing materials as nutrients and circulating them in a healthy and safe manner. So quite ambitious. And clearly our ambitions were recognized by the Green Apple Award panel, which was great. So why do we need another eco-rating tool? I think it's clear that we feel that there isn't a tool that adequately brings together an eco-efficiency assessment and specification of building elements for the circular economy. And there's a need for an improved approach for circular economy, sustainable design and build decisions that fundamentally close what I think are three recognized gaps in the construction sector. And in the construction sector, those life cycle and cradle-to-cradle problems, or gaps, if I can call them that, are clearly performance, environmental impacts, and affordability. So we're chasing nirvana, and in doing that, clearly those three gaps are where we see the challenge. In doing our thinking and development, we want to tackle, obviously, buildability. Build twice, off-site and then on-site, ideally. Habitability is key. Affordable life cycle, sustainable health designs in terms of materials and fabrics. And then obviously we want to make sure that we get the right ecological fit for purpose in terms of considerations to the planet and habitability. And then in terms of the way we want to think about this is a virtuous circle for change. So whatever we do in terms of our projects, it's a bit, we want to go around in a continuous improvement life cycle by learning the lessons, identifying the lessons, learning them, and then obviously improving what we're doing. In closing the gaps and in thinking about how we wanted to do all of this, we started with an eco-efficiency framework, which was rather cumbersome. We undertook some modeling with a number of projects, which I'll touch on shortly. The aim of the framework clearly was to close these three gaps by best integrated building techniques to achieve an NSBM eco level, which, if you like, is the green there shown at the top, which is obviously the best affordability, best performance, and the highest ecological value. This meant integrating and thinking about qualitative and a whole bunch of quantitative assessments in terms of the materials and fabrics. And then we'll come on and talk a bit more about the qualitative in a short while. And that might even mean looking at health and safety costs and considerations, retrofitability versus new. So if you're doing something for new build, is it applicable to retrofitability, and vice versa? That was our considerations, and certainly thinking about what BRE might provide as a tool, we wanted to make sure we were covering those things that aren't covered to try and be holistic. So in that framework, we built a prototype in terms of what we wanted to do. We modeled that. We did a comparison against Passive House Standard and building regulations. And rather pleasingly, we validated our approach to confirm 40 to 50% reduction in CO2 emissions and running costs compared to building regulations in the UK. So we knew we were on the right track. And in obviously endeavoring to make this process robust, we needed to think about a material database and start building that information, thinking about modern methods of construction, off-site to on-site, and then obviously the costing issues and the design issues focused and centered around building information modeling. And that's obviously led us to create this NSBM Eco-rating tool, and we then go around and we call our virtuous circle of continuous improvement. So just unpicking that a bit, the material database, obviously I'm repeating what I said earlier, but we wanted to create an inventory of sustainable materials with the right performance criteria for buildability, habitability, and obviously the environmental impacts. Important in the life cycle thinking is the durability of the products and the finished building in terms of maintenance, and then obviously the final disposal. And our ambition, of course, is to make sure from a circular economy perspective and cradle-to-cradle thinking that the reuse of construction materials is considered, i.e. designed for deconstruction. And ultimately, of course, we want everything to be healthy and to avoid the toxic hazardous chemicals in construction and use. Clearly, in our thinking, everything needs to be thought through in terms of fixing those three gaps. And then building information modeling, this is important in terms of building twice. So we can build virtually and obviously iron out the issues that avoid expensive real building issues by avoiding and detecting clashes at an early stage and improving the quality of what we're delivering and reducing costs at every stage. Then we're obviously going to tackle that affordability gap criteria. And importantly, obviously, we're using building information modeling which is where the sector's going, building sector's going. We can obviously improve our partnership and stakeholder cooperation and thinking and reduce cycle times. So I think that's hopefully a good scene setter. Now I'm now going to hand over to Dr. Craig Jones, who did a brilliant job in interpreting mine and Alex's thinking with respect to the NSBM eco-efficiency approach, and created the eco-rating tool, which we're now beginning to use and learning about its utility. Clearly there are some improvements and needed in due course, but so I'll hand over to Dr. Craig Jones now. Craig.
Thanks, Danny, and hi everyone. So I'm talking about the next section of slides. I'm Craig Jones, and I work at Circular Ecology, and we worked with NSBM on the eco-rating tool. So I'll be talking through this section, but Danny still retains control of the slides, so you might hear me asking him to move to the next slide. So I've got a selection of slides which are all mainly quite visual, showing you screenshots of the actual tool. So the tool captures all of as much of what Danny just introduced as it possibly can, with current information and knowledge. And it's an Excel-based tool, so it puts all this in Excel, and it's quite easy to use, drop-down menus and input boxes. So these are just a couple of screenshots of the tool. But on the next slide, we have a broad overview of the how the tool works. So if we could go to the next slide, please, Danny. Great. So as Danny mentioned, important to understanding the environmental impacts of constructions and buildings, you need to understand the impacts of materials and products themselves. So the tool, fundamental to tool is relying on a database for materials and products, and this database uses an EU-wide standard called EN 15804 towards the top of the slide there. And this is in a series of standards that's on the sustainability assessment of construction works. That specific standard, EN 15804, is actually for the environmental product declarations, which are a short document which tell you the environmental impact of making a construction material or a construction product. Now, the EN 15804 framework actually has many environmental and resource use categories, so it's ideal for assessing such a broad range of issues that NSBM wanted to look at, and it also offers a data source there to use in the tool. So that forms the basis of the product level data, and that framework actually has 24 environment and resource use impact categories, and in the slides that are coming up we have some examples of those impact categories. But the way the tool works is it takes product level data for the materials and the construction products. It then feeds it into the element level framework, which is where you can piece together, for example, X kilograms of bricks plus Y kilograms of cement equals, for example, a meter square of brick wall, or it could be a floor construction, a roof construction, any type of building element or assembly. So the tool then moves on to the final level, which is the building element framework, which is where you select from the building element framework, you select the different elements, so how many meters squared of different types of external walls or ground floors or roofs to make your building. And you can compare 3 buildings side by side in the tool. And the broader framework that it does do is the EN 15804 is the product level standard that I've mentioned, and the higher building level framework is EN 15978, which is on sustainability assessment of construction works. And sometimes you see it referred to as CEN TC 350. So these are really important standards and frameworks on the sustainability assessment of construction works. But because those environmental indicators don't actually cover everything that NSBM wanted to, there's also quite a few qualitative indicators as well in the tool and in the framework, and we'll go over these in the next slides. So if we can move to the next slide, please, Danny. We have some screenshots of the tool itself. So starting at the bottom level, we have the materials and products database, which is taking, for example, compliance studies to EN 15804 and also environmental product declarations. Now, in the current state of the data out there, there's not studies to EN 15804 for all kind of products, but at the moment, but there are hundreds and hundreds of pieces of data out there. So what the tool does is it has data entry for the environmental impacts of individual construction products. It could be a brick, it could be insulation, it could be a roof tile, it could be a window, it could be anything. But it captures the functional unit of the piece of data. It could be a meter cubed, a meter squared, a kilogram, and then it starts to add the environmental impacts. So to the right of the slide here, you have the first out of the environmental impacts. You have the global warming, which is the carbon footprint or the embodied carbon of the product material, depletion of elements. If we go to the next slide, please, Danny.
Sure.
We have most of the EN 15804 environmental impact categories there. I can't see the next slide.
Yeah, just moving now.
Yeah. But we have other kind of impact categories such as eutrophication. On the left of the screen here we have eutrophication, then we have photochemical ozone creation, Depletion of fossil fuels, so the use of renewable energies versus non-renewable energies. We have the use of recycled materials, the net use of fresh water. Of course, water is becoming a more important topic. We have hazardous waste disposed, non-hazardous waste disposed, and on the next slide, these are all indicators in the EN 15804 framework. So it's a lot to consider, but it captures data on all of this. And then we also have components for reuse, materials for recycling, materials for energy recovery, and that's the data from EN 15804. The other data that's not part of that standard, but part of the tool, is the lifetime of the construction product and also the installation waste rate, because these are considered in the whole cradle-to-grave assessment of the building. Moving on to the next slide, I believe we have exactly the same, but for the end of life of the construction product. So these environmental product declarations pretty much almost always have end of life impacts as well. So what happens at the end of life of that construction product when it goes to recycling or disposal, what's the environmental impacts of that? So that's also captured in the product level database. Moving on to the next slide. We have the qualitative indicators, and this is where we consider a much broader range of issues that are not covered by the EN 15804. So we have such things such as toxicity, pollution index. Toxicity, although it's a really important impact, it wasn't picked as one of the EN 15804 indicators because it is one of the more uncertain result categories from life cycle assessment type work, but it's still a really important issue. So these qualitative indicators are where it allows that to be considered. Also things such as retrofit capability, occupant health and safety, climate change resilience, etc. So this series of qualitative indicators allows a much broader range of issues to be captured and considered in the environmental assessment of a building. Now, the tool also allows the building operational energy and maintenance impacts to be included. So it's not just about the embodied impacts of the construction, the building and all the products. It also captures the impacts of consuming electricity and gas from the building. It also considers the replacement of materials in the building. So for example, if a floor tile is estimated to have a lifetime of, let's say, 30 years and the building a lifetime of, let's say, 60 years, the tool will replace the tile once in the lifetime. So over the full 60 years, it accounts for 2 tiles in the lifetime. So that's all captured in the tool as well. We move on to the next slide. The product level data then feeds through to the element level, and this is where you can pick how you can start to build different building elements. You might want to build, for example, an external brick cavity block wall versus a timber wall with natural insulation. You can build up any different number of types of elements that you want. Also, the transport delivery distance of the materials is entered at this stage. Moving on, the element framework then goes on to the final level, which is the building level framework. And this is where, through drop-down menus, you can enter all the different building elements to create an entire building. Could be a house, could be an office, could be any kind of non-domestic building, or indeed a wider type of construction project. So that's where you enter the floor area of the building and the area of external walls and floors, etc. And then it goes through to results. So if we move on to the next slide. Here we have examples of results. These are just a couple of screenshots. There's the visual results, like the graph on the left. There's the numbers, breakdowns by different life cycle stages, and different breakdowns of the data, and the results for qualitative indicators as well. But it's at this stage that I believe we're handing over to Alex to talk specifically about a real case study, I believe.
Yeah, I'm going to try and bring this up now. Maybe some technical difficulties. Just bear with me a minute.
Great.
Okay. Go, handing over to you,
Thank
Craig, from Craig to Alex.
Thank you, Craig and Danny. Good afternoon, everyone. Yes, as a part of our NSBM eco-efficiency framework, we use this Eco-rating tool to assess a test project that we had last year. This is a single-story residential project that we did in South Hampshire, and it worked well, really worked very well. We first started using this tool at the product level frame, where we introduced our material database. Then from there we move on to our building element frameworks. So there we assign our fabric options that we identify were the best options for that building. And of course, at the end, we compare that with, in the building framework, with traditional floor construction. And the results were really very impressive in the sense of we basically got a 50% reduction on the eco points on our new standard performance building against what it was a traditional construction. We're talking about the traditional construction, to make it clear, we are talking about, for example, normal aerated concrete block works and face bricks with the insulation could be, for example, a Kingspan cavity board in a partial fill cavity wall insulation. So that's what we are comparing. So really, these are all good news. We know, apart from that, not only we are taking that big advantage on the environmental impact, reducing up to 50% of what it was, but also we compare that with the cost, which is another element that this tool can bring us, and we are not more expensive, which is very good news. So we are on the right track. I don't know if we have another slide there, Danny, to show. Yeah, which is again, we are probably 40% less expensive compare. We're talking here about just materials. We are not talking about labor, which is another concept that we are working on at the moment with the modern methods of construction, that we are intended to reduce this even more, trying to build off-site and assemble on-site. So this is the elements. That we have another table there showing and comparing traditional construction with this designed standard performance chosen for this work. If you want to add anything else, Danny, to this?
No, I think that's fine, Alex. I think what this did was very pleasantly confirmed and validated the modelling we did with Anglo-Ruskin University with the passive house benchmarking and building regulations, where we were identifying a 40 to 50% reduction, and then actually doing this for real. And this was borne out in the same ballpark figures, which was very heartening.
Yes.
Okay. Any other slides you want to show the audience? I mean, I think there's another slide here. It just shows environmental impacts by life cycle stage. Again,
yes. Again, we have been dealing what we found at the moment. This is a little as the early days for our journey. We couldn't find more than what it is. We can't find more than what it is. Stages 1 to A1 to A3. Which is cradle to grave. but basically I hope that all these manufacturers are starting to develop more information so we can use all of these stages up to the whole life cycle of the elements.
Yeah, I think that's right. And I mean, our challenge in NSBM is the materials database. And as Craig pointed out, you know, some of the manufacturers don't provide this information, but actually in tidbits of information is around in different forms. So it's coalescing that and capturing it and making use of it in a sensible way. I think the other factor is, of course, we look at the high impact elements, and if we can't, and that's where we will focus. And if we can't find the data for the low impacts, then obviously that's unfortunate. But at least that means we're trying to demonstrate to the client, you know, our NSBM eco-efficiency approach is true to the principles of what we're trying to do, and that's across the life cycle. So that's our thinking. Okay, anything else, Craig? Alex, sorry on that.
That's okay, thank you, Danny. I think we cover more or less what it is, our test project. And
yeah, okay. So any questions on that? You can pick up on that. Great. Just waiting for the screen to catch up. Okay, I think it maybe just worth touching on the qualitative indicator results. I think Craig picked up on that and indicated that there are some things that are not covered with respect to EPDs. And then when you're thinking about what we're trying to achieve in terms of eco-efficiency with respect to you know, the definition of that, circular economy and cradle to cradle, and then trying to close those three gaps in terms of performance, affordability, and environmental impacts, you know, you just can't necessarily get at the quantitative side of life. So we have created these qualitative indicators, and one of those might be, you know, building biology, occupant health, where we need to make an assessment for the client. Climate change resilience, you know, flood resilience, that sort of thing, where you don't necessarily get that fully considered, and some clients will obviously be discerning in respect to climate change, adaptability and resilience. And then one of the other things, of course, is that whatever we try to do, as I said at the beginning, is, you know, retrofitability is the biggest challenge in the UK or globally in the modern world, and that's the hardest challenge. Whatever we do in terms of developing something for a new build, we want to consider its applicability to retrofit, and that's been quite important in driving us. Where there aren't EPDs, we would look at eco-labels and other certified environmental performance accredited systems, and that can be a bit of a challenge. So that's qualitative indicators, and I think really that covers everything we wanted to say about the Eco-rating tool. And as I said at the beginning, it was very heartening to put that all together as a story, as a result, a validated result, and get the Green Apple award. And no small thanks to Craig and Circular Ecology in helping us do that. So that was a fantastic result for us, and I think for building construction thinking. So tremendous. Okay, so in summary, the tool does help us provide pathways. In fact, it doesn't help, it does provide us with an eco-efficient standard, which is more than carbon equivalent assessment of buildings in operation and embodied energy. And that's quite important to us and to many clients. And the integration of those qualitative and quantitative considerations into that single assessment score, which closes the affordability, performance, and environment gap, including obviously the prerequisites of buildability, habitability, and the ecological fit, has been very important, and we believe have been quite successful in that. And then obviously the circular economy is very topical at the moment. Needs must, resource depletion is going to be driving costs. So of course, where we can sweat the assets and pick and select and specify sensibly at the outset of the project, you know, ethically and financially across the life cycle. That's got to make sense, and it avoids obviously unacceptable impacts on people, communities, and the planet. So that's our eco-rating tool. Very happy to take any questions. Hello? Anybody there? Alex, can you hear me?
Hi, I'm here. I'm Craig.
Yeah, hi. So I'm just going to open up the audience, which you can't see at the moment.
Just whilst Danny's doing that, this one, I think I didn't touch on too much, is how the tool condenses the multiple environmental and resource use impact categories down into eco points.
Sorry, carry on, Craig. Okay. Sorry, I hope you can hear me. Seems to be a few technical problems. I'm not sure what the issue is. Alex, can you hear me? Alex?
Yeah, Danny, I can hear you now again. Yes, something happened.
Yeah, hello, Craig. Can you hear me? Hello, Craig. Hi, Craig.
So we lost him.
Hi, can you hear me now?
Sorry, did you just say that last bit again, Craig? Sorry, I think we might have just lost the connection for a minute for some reason.
Yeah. So the tool takes this multiple environmental and resource use categories. There's 24 in the full EN50 native floor, and it takes the bigger percentage of them, condenses them down into eco points, which is a single score answer. And it does that in a kind of similar approach to the way that BRE will do it, in that it takes those scores and it compares it to the average environmental impact of one person in Europe, and compares the impacts of the building that you're looking at to the average impact of a person in Europe, for example, for climate change or freshwater use or eutrophication, etc. And then it adds them all together at the end in eco points, where lower is a lower impact and higher is a higher impact.
Just looking to see if anyone's posed any questions. I don't seem to have received any questions at all. If somebody wants to put their hand up, I can put you on speaker if you wish to ask a question personally. I'm not seeing anybody raising their hand. Just wait for anybody to think about any questions. But as I said at the beginning, if you've got questions you want to pose to us by email, that's absolutely fine. Hold on a minute, I just see there may be some questions coming up now. There's a question here from Zach. My question is that are the environmental data for products like brick, wall, static or dynamic? When I mean dynamic, I mean that they are approximates. Craig, I wonder if you could answer that.
If they're approximates, some of the data is specific to manufacturers, so environmental product declarations sometimes are done by an entire sector, so you'll get an average of all bricks, for example, so it could be an average of all bricks in a country, and some of them are manufacturer specific, so manufacturer A will make their own environmental product declaration, and manufacturer B will make their own different environmental product declaration.
Yeah, and there's some questions from Anna. She says, hi, you mentioned some qualitative indicators at product level. namely retrofit capability and resilient for climate change? Yes, we did. Sorry, I don't see the rest of the question there, Anna. So I'm not sure what you're asking, but I think suffice to say, clearly at the product level, if there is a need to consider retrofit ability and you think about new build, yeah, sure, why not? And that's certainly where we would aim to focus our thinking in terms of what we're doing, because I have an approach to life which is I call worm, write once, read many. I think it's the same, do once and do many if you like, and if you can do that, why wouldn't you want to do that? And the same in terms of resilience for climate change, where products don't last across the life cycle. So if you can select something which does last, then fine. And I think, again, that's something you don't find in some of the data. I don't know if anybody wants to comment on that, otherwise I'll go on to the next question. And then Anna asking, how can you really measure the affordability to retrofit by using them? Do you mean using relating to the previous question? Well, I mean, that is a challenge, but clearly, if you're replacing items on a regular basis, clearly maintenance costs are going to increase, and so I think you can do that. You can do that calculation by replacement cost, and that's something that we would aim to be thinking about when we're doing the material database and at the specification stage. Okay, so you were saying I've got a few problems in communication. Apologies, and I'll move on and answer some of the other questions just in case it's maybe just you. Question from Stephen Allen: did the tool give any surprises in terms of environmental performance? Alex, do you want to answer that perhaps, because you took a look at this recently?
On the environmental performance?
Yeah.
Sorry, Danny.
Yeah, so I mean, Zach, sorry, Stephen's asking, did the tool give any surprises in terms of the environmental performance? I mean, I think we initially thought there were some, I'm just going to put up this, you can see this slide, can everyone see this slide? Yeah, so here's some performance. So acidification, 52%, that was quite high.
I think it was a little high, yes, yeah. And
I think we, Craig, I think we said that perhaps some of the EPDs may have had some errors in some of the data sets, and that's something that we need to be alert to.
Yes, hi everyone. So the EN15 ASO4 standard is fundamental to how the tool works, and it contains 24 different environmental and resource use categories. But I think it's fair to say that actually the current level of data doesn't measure all of those 24 environmental and resource use categories accurately at the moment. So there's still a bit to go in some of the indicators to get the accuracy up. And in particular, we had trouble with the abiotic resource depletion, where the EN15 was originally released in 2012, and it didn't have much guidance on how to calculate all the indicators. An update was released in 2013 that had more guidance on how to calculate the impact categories, so that's helped, but perhaps some of the EPDs haven't caught up yet. But one thing the tool does do is it shows where the environmental impact hotspots are, which is quite interesting because it compares the different impact categories against each other. So how important climate change is versus water for the product you're looking at, or eutrophication, which is pollution of water resources, etc. So that's quite interesting to look at.
Okay, thanks, Craig. I think going back to next question, because I think I'll probably answer one of Anna's, is there scope for the tool to handle calculations for non-conventional materials such as compressed earth, bricks, and bamboo? I think it goes back to you, Craig, in terms of where is the data, are data sets available for that? I don't think there is much on that.
Well, it can. There's no reason why the tool can't do that. The main barrier to that, which has existed for as long as I've been doing these assessments, is data. So one of the main challenges is the manufacturers of natural materials often don't have the resources to study the environmental impacts of their products to produce an environmental product declaration. There is some data out there for some natural materials, but it's always a challenge to get data for the more natural materials, unfortunately. But there's some data out there, and there's a bit of data in the tool on that as well already.
Yes, it's interesting to mention. Probably this is an analogy of what happened with BIM when we started our journey a year ago, and we couldn't find objects there were some generic ones coming with some software, but then after manufacturers started, as they saw that that was going to be the route to take. And I think we are early days again, as I said before, with the EPDs, and manufacturers are starting to realize that there is a need to understand how these materials are behaving. So really, this is a little what's happening and why we find it difficult to find these materials at the moment.
Yeah, that's right. And I think the other thing is in our approach, is there scope to handle calculations? Well, you've already answered that. But in terms of habitability, buildability, particularly, you're talking about bamboo there. Well, will it pass our buildability thinking in our eco-efficiency thinking? Well, that depends. So, whether it's a downpipe or guttering, if you go to the tropical parts of the world, they use that quite successfully. But in terms of buildability with the trades and building off-site to on-site and making that work, that would be quite challenging. And then of course, it's the transport movement. Clearly, if we can resource these things locally, then so be it. But if you have to bring it a long way, you need to do that cost-benefit thinking. And I guess that's the challenge, because you're back then into all sorts of carbon energy calculations, aren't you? In terms of getting the thing to site and then assembling it. So Ian asked a question. Right, what is the basis of your qualitative measurements? Your views of what is important, or do you put them through from other standards? Well, I think one of the qualitative measurements we picked on, Alex, was health and safety, which we know is a big overhead. So in terms of the off-site to on-site bit, the more we do off-site, then you can reduce the on-site costs, and all of that has an environmental consequence in terms of transport and so on. Do you want to say a bit more about that, Alex? Because obviously it's a big overhead for any organization in putting a building together.
Yeah, of course. Talking about health and safety, we know that's a big challenge, and UK regulations are really tough, and we need to do something about this, apart from what we have been doing during the last 50 or 60 years in the construction, and nothing changed since then. If we work in a controlled environment, of course, we can maneuver these risks and take a good advantage of what it is, apart from reducing cost, as we identify also. Yeah,
I think the other one qualitatively, because we couldn't find a lot of data for cradle to cradle. So Ian, I think our thoughts were, go and look at the cradle to cradle collection of stuff, if you like, and ask ourselves, is there something that we could pull through quantitatively? And I don't think we found very much. So that again is a qualitative judgment that we would make at the specification stage, as best we can, pulling that information from as wider resource locations as possible. So that certainly is an issue. And in terms of the building biology, those who follow the German way of doing things, Baubiology is very important. Are there standards? Yes, I think you'll find in the States there's an adoption of that thinking. Standard in its own right. In the States, probably not. In Germany, certainly they would say it is. And it's as simple as thinking about the health of the individual, and then designing in, for example, the way that you kit the property out in terms of sockets and switches and so on. So you're reducing EMF, the electrical supply, to your location where you're sleeping. and then that also includes specification of lights and LED, making sure the right spectrum of thinking in terms of that, so that you don't impact on people's sleep patterns or general well-being, because this is becoming a big issue as we switch over from the old lighting system to the new lighting system. But of course then there's benefits, isn't there, about energy saving as a result of specifying the more modern lamps and so on. So yeah, and I think, you know, there's a lot there. I see Anna's just asked a question. What qualitative standards are you using for assessment of product toxicity and its impact of health and well-being on manufacturing, construction workers and end users, for example, in insulation? Anna, that's a great question, and I think Alex will tell you that we used in our South Hampshire project sheep wool, and I recall the guys who were doing the work saying, that's the first time I've gone home at the end of the day not feeling itchy because I've got the rock wool itch, you know, and the glass fiber scratching and so on. And goodness knows what these guys are breathing in. So you know, in those terms, it's a win-win, isn't it, for the environment and for the individual construction worker, and of course the end user in some instances. Alex, do you want to comment on that?
Yeah, well, just to remark that we use natural fiber insulation, which is sheep wool. In this case, we use the brand Thermafleece, and with great results. And remember, we not only were making good in winter time, but also it works very well during summertime when we need to prevent overheating, which is another big issue that we identify in buildings, particularly in this one, old ones, and we're doing retrofits. And then we started to put insulation and make it airtight, and then that's things coming. Now, overheating is really a big issue.
Yeah, and I think, and Anna, just to expand a bit further, again, this picks up what Craig was saying, the toxicity and the measures that and data that might be available are not that widespread in terms of being made available to us. And in fact, I've been at exhibitions, and you ask the manufacturer, and they just clam up and say it's commercial in confidence, and they just don't tell you the truth. And you can clearly work out for yourself that, you know, there's some kind of toxic chemical that's used in the process, and then, you know, how much of that is still residual and potentially would leach into the building and impact on the health of the occupant. So that's not great. I think there's the in our eco assessment framework we were using, I think it's called the red list, where you can identify some of the top materials that use formaldehyde and a number of other toxic chemicals, and so yeah, it's back to what we were saying. It's a trawl across the spectrum of understanding, and I think luckily with a bit of a chemical knowledge that I have, and Alex's knowledge of construction and experience over many decades, we can identify pretty quickly and specify for the client what's the right material fabric to use. But I'm not sure that everyone's lucky enough to have that knowledge, and it's difficult to find that in one resource, one database. So that's why we're building our own materials database to help us on the journey to get the right solutions and close those three gaps. So that was a question from Anna. I'm not sure I've answered all your questions there, but yeah, building biology I've mentioned. Are there any other questions that we need to cover which I've missed out on? No, I think we've covered all the questions. I'm not sure I answered Anna's question particularly well about affordability to retrofit. How can you really measure the affordability to retrofit? Yeah, I don't know, Alex, if you want to say anything more on that. This is a real challenge, isn't it? Because putting something into an existing building, dismantling it and then putting it back together again using a mix of old and new products is not great, is it?
It is, but in fact, in this test project, we had a little issue there, which was due to, we have these tough planning regulations, and then one of the neighbors that have been inquire about if they were happy with what the extension of this building was going to be, mentioned at any point to the planners that they were not happy to knock down a drop wall really was. And I remember at that point that the value of this way to build was exposed, because we literally built off-site that wall and assembled on site, and then we're talking about the affordability. Really, well, it was a precious gift to put that wall there at that point, because if not, probably we should have changed the design at that stage and probably have to come up with another solution. So it's very difficult to really try to talk about affordability there, no? And that depends also what sort of resources are you finding on the site, what sort of fabrics are you finding, and what's the owner or the client is requesting to build there.
Yeah. So I think that probably brings us nicely to an end. I hope that all of you who have joined us have enjoyed our overview of the Eco-rating tool and the fact that we got the Green Apple Award, which we're very proud about. And no small thanks, as I said before, to Dr. Craig Jones. We obviously are on a journey. I think we're very heartened by the results that we've achieved so far. I think the cynics would say that being sustainable costs much more. I think what we have been demonstrating, and certainly our modelling has demonstrated in our small few projects that we've done, have demonstrated it actually doesn't have to be much more. So I hope that flies in the face of reality of what some people believe. And clearly what we need to do is get on and do more projects and demonstrate that by specifying eco-efficient and cradle-to-cradle thinking in terms of product selection, actually integrating it in the right way, ensuring buildability, always thinking about habitability, and then obviously making sure that the ecological impact is right. And it's not just energy and carbon assessment, which I think is where current thinking is hung up. But of course, we all know why that is. Craig, I'm sure you'll remind us that the embodied energy, operational energy, and all the various other carbon and energies, are small amounts compared with what you're trying to measure, which is carbon in use and embodied energy. And then obviously construction materials is a small amount, I suppose. Craig, I don't know if you want to say anything more on that before we sign off.
It can be quite a big fraction of the pie. It depends on the building, but it's the embodied impacts are getting a bigger percentage of the whole life impacts, because thermal standards are coming down, but the embodied impacts not as much has been doing to reduce it. But it can be a quarter, a third of the whole life embodied whole life carbon.
Yeah, and I think we in New Sustainable Building Model Limited have a dilemma, that the industry would suggest that passive is the way forward, which it probably is in terms of energy thermal efficiency terms. But actually, when you then look at the products and the techniques that are used to do that construction, well, is that really compatible with true eco-efficiency? And that is the debate we have internally. Yes, the passive approach is we believe the right approach, but making sure you don't go down and follow slavishly current material uses without considering the wider applicability of the eco-efficiency approach. So I think that's where we're at, and we hope to prove through further projects that our thinking is right. So I think that neatly brings us to conclusion. As I've said, the recording, the webinar is recorded, the slides will be made available, and if you have any further follow-up questions, please send them to ourselves. That's either Dr. Craig Jones at Circular Ecology, or to myself and Alex at New Sustainable Building Model Limited. and I'll just put up again at the end here the email address, which I think you should all have from the welcoming slides to this webinar. So there's our website addresses, and the invitation has the details as well. So thank you from me. Alex and Craig, anything final to say?
Just thank you to the people who...
That's been great. Thank you from me as well.
Okay, thanks very much indeed. So that completes our webinar. Thank you guys, and hopefully we'll follow this up in due course with another one. Cheers, bye-bye.